of a constant, then PV is equal to K1. Here P is the pressure and V is the volume of the gas. We can also say that P1 V1 equal to constant equal to K1. P2 V2 equal to constant equal to K1. So, we can relate P1 V1 is equal to P2 V2. P1 V1 is equal to P2 V2. Boyle's law graph. A plot of P versus 1 over volume at constant temperature for a fixed mass of a gas would be straight line. Straight line passing through the origin. If we plot a graph between pressure and volume, 1 over volume, the graph will be straight line. A plot of P versus V, pressure versus volume at constant temperature for a fixed mass of gas would be rectangular hyperbola. A plot of P versus V at constant temperature for a fixed mass of gas would be a rectangular hyperbola. A plot of P or V versus PV at constant temperature for a fixed mass of gas would be straight line parallel to pressure. It shows change of volume with pressure. Volume is taken in x-axis and pressure in the y-axis. This graph shows variations of inverse of volume with pressure. It shows a straight line since volume is inversely proportional to pressure. Charles' law. In 1787, Jacques Alexander Charles, a French chemist, discovered that with the rise in temperature, carbon dioxide, hydrogen, oxygen and nitrogen expand at constant rates provided the pressure is kept constant. This is known as Charles' law. With the rise in temperature, carbon dioxide, hydrogen, oxygen and nitrogen expand at constant rates provided the pressure is constant. This is known as Charles' law. This is also known as Charles' gas law. Charles' law describes the relationship between volume and temperature of gases. Volume and temperature of gases. He studied the relationship between volume and temperature around the turn of 19th century. He determined this law for equal amount of gases at constant pressure. So, V-T is equal to constant. He studied the relationship between volume and temperature. This defines a direct relationship, which means an increase in one results in an increase in other. At constant pressure, the volume of a given mass of a gas increases or decreases by 1 over 273 of its original volume at 32° Fahrenheit for every degree centigrade rise or lowering in temperature. Charlie's law states that at constant pressure, the volume of a gas is directly proportional to temperature. The volume of a gas is directly proportional to temperature of the gas. The law can be understood by keeping the pressure constant. Charlie's law gives a direct relationship between volume of the gas and temperature of the gas. Charlie's law, it gives a relationship between volume of the gas and temperature of the gas. Effect of temperature on volume. When the temperature of the gas is increased, the volume of the gas increases. When the temperature of the gas is increased, the volume of the gas also increases. Charlie's law, V1 over T1 is equal to V2 over T2. Charlie's law is V1 over T1 is equal to V2 over T2. Charlie's law can be represented mathematically as temperature directly proportional to volume. Temperature is equal to constant into volume, or volume is equal to constant into temperature. Volume and temperature can also be related as V over T, volume over temperature is equal to constant. If K is considered to be the constant, then Vt is equal to K. If K is considered to be constant, then Vt is equal to K, where V is the volume and T is the absolute temperature. Since V over T is a constant, then V1 over T1 must also be a constant. V2 over T2 must also be equal to constant K. So we can conclude that V1 over T1 is equal to V2 over T2. This equation is also a form of Charlie's law. Graph showing the variation of volume of the gas with temperature. The graph shows the variation of volume of a gas with temperature. The graph draws at constant pressure is called as isobar. It can be seen that with increase in pressure, the volume occupied by the gas is less. This can be attributed to the Boyle's law. Next is Avogadro's law. Amedeo Avogadro introduced the term molecule and distinguished it from atom. According to Avogadro, particles in the gaseous state do not exist as atom but as molecules. The particles in the gaseous state do not exist as atom but as molecules. In 1811, he proposed his famous hypothesis known as Avogadro's law. The law states that Avogadro's law states that equal volume of all gases at the same temperature and pressure contains equal number of molecules. What is Avogadro's law? It states that equal volume of all gases at the same temperature and pressure contains equal number of molecules. Avogadro's law can be expressed by the formula Vi over Ni is equal to Vf over Nf. Vi is the initial volume, Ni initial number of moles, Vf is the final volume, Nf is final number of moles. So Vi over Ni equal to Vf over Nf. Ideal gas law. Ideal gas is one which obeys gas laws at appreciable range of temperature. It obeys Boyle's law, Avogadro's law, it obeys and Charlie's law. Ideal gas obeys Boyle's law, Charlie's law and Avogadro's law at all temperature. Relationship between ideal gas law and individual gas laws. PV is equal to nRT or V is equal to nRT over P. Boyle's law is V equal to constant over P. Charlie's law, V is equal to constant into T. Avogadro's law, V is equal to constant into N. So, PV is equal to nRT. This is ideal gas equation. Ideal gas equation. PV over T is equal to nR. P over V, PV over T is equal to constant. Ideal gas equation. A gas which obeys all the gas laws under all the conditions of temperature and pressure is called ideal gas. Gases which do not obey gas laws under required conditions are called real gases. Real gases show the behavior of ideal gas at high temperature and low pressure. So, today we have discussed Charlie's law, Boyle's law, ideal gas, perfect gas, and ideal gas equation. So, this is all about. Okay, thank you.